I am Uday Surya. Today we are going to see about visual versus pure visual, despairing C++ polymorphism. Let's go. Understanding polymorphism in C++, a quick overview. The ability to treat objects of different classes in a uniform way. One interface multiple forms allows objects to take on different forms based on their context. Compile time versus runtime. Distinguishes between static and dynamic polymorphism. Inheritance is key, achieved through base and derived classes, often with visual functions. Visual functions enabling dynamic method dispatch. Function declared with a visual keyword in a base class. Runtime resolution ensures the correct function version is called based on the object's actual type, not the pointer or reference type. Overriding. Derived classes can provide their own implementation of visual function. Pure visual functions defining abstract interfaces. Declared by assigning equals not to a visual function in the base class. No implementation. A pure visual function has no implementation in the base class. Abstract class. A class containing at least one pure visual function becomes an abstract class. Enforced overriding. Derived classes must provide an implementation for all pure visual functions or they do become abstract. Key distinctions: visual versus pure visual. Feature: implementation in base class. In visual function, it is optional. In pure visual function, none. Instantiation in base class. In visual function, possible. In pure visual function, not possible. It becomes abstract. Overriding in derived class. In visual function, it is optional. In pure visual function, it is mandatory. Purpose: in visual function, allow dynamic method dispatch. In pure visual function, define an interface for derived class. Use cases for visual function. Flexible overriding. Customizable behavior. When an base class provides a common function but derived classes might need slightly different behavior. Default implementations. When most derived classes will use the base implementation but some might override it. Extensibility. Designing libraries where users can extend functionality by overriding methods. Use cases for pure visual functions. Enforcing construct. Mandatory implementation when derived classes must provide specific functionality to be complete. API design. Defining clear interfaces for complex systems, ensuring all components adhere to a standard. Ensuring consistency. Guaranteeing that all objects of derived classes will have a certain set of methods, prevent runtime errors.